these problems we're asked to find the vertical asymptote, and one of our first steps in doing that is to factor and see if we can cancel out any common factors. The common factors that we cancel out is where there would actually be a hole and not a vertical asymptote. So by this first example, there's really nothing you can factor out of the numerator except the number 1, and the same for the denominator. Since we can't factor either of these two, then we go ahead and set the denominator equal to 0, solve for x, subtract 7, divide by 2, and that would be the equation of our vertical asymptote. Remember, vertical asymptotes all have the equation x equals some number, but it's always x equals for a vertical asymptote. For part B, I see that I have x squared minus 25 in the denominator, so that is something that you can factor. It's the difference of two squares. The numerator doesn't factor. I mean, I can pull out the number 1 if I want, but that's it. The denominator factors into x plus 5 times x minus 5, difference of two squares. Notice the x minus 5s can cancel. They're the same factor. So where I have x minus 5 canceling, this is where I have a hole at x equals 5. It's not going to be part of my vertical asymptote. In fact, now I look at my reduced fraction, 1 over x plus 5, and I focus on setting that denominator equal to 0 and solve for x. So this is where I would have a vertical asymptote. At x equals positive 5, that's the factor that canceled out, so I set it equal to 0, solve for x. That's where you're going to have a hole in the graph. It's an actual physical hole. And let's try it again with this one. The denominator looks like it's going to factor. The numerator, not so much, but you can always pull a 1 out if you want. Now the denominator factors into x and x. I get positive 24. I need a plus 6 and a plus 4 because it also needs to add to 10x. Double check it, FOIL it out, make sure it works. Now in this problem, nothing cancels. So I'm not going to have a hole in the problem like I did in the previous one. I simply set the denominator equal to 0 and then solve for x. So take each factor and set it equal to 0. And this is where your two vertical asymptotes will be. You can have more than one. In this case, I have one at x equals negative 6. Subtract 4 from both sides here. X equals negative 4. This is where I have my two vertical asymptotes. And no holes. Let's try this last one. Again, it looks like something that can probably factor, so you might want to try. I'm going to write down my two sets of parentheses. X times x to get x squared. Multiply to get negative 7. I don't have a whole lot of choice. 7 and 1, but the signs have to be opposite. And in this case, they have to add up to negative 6, so you need to FOIL it out. Make sure that it works out to negative 6x in the middle. For this one, because the a is not 1, we're going to factor it as 2x times x, which is 2x squared. And then go ahead and put in your 1s, minus 1 and a plus 1. And then again, check to make sure that it adds up to a positive 1x. So we have a plus 2x and a minus 1x. That adds up to a plus 1x. Now from here, we do have a factor that cancels. So off to the side here, at x plus 1 equals 0, I'm going to have a hole. solve for x, and that's where your hole is. It's not your vertical asymptote, but where your hole is. So I come down here with my reduced fraction, and now I find the vertical asymptote by setting the denominator equal to 0, solve for x. So 2x equals 1, or x equals 1/2. So at x equals 1/2, that's your vertical asymptote. And where it canceled out, that's where you had a hole.